Welcome back. Hope you have had a nice break. Are there any questions? Any questions? Okay, before break, we did example 3, example 4. Now let's move on example 5. So, example 5. Let's see. This example 4. Try to locate example 5 data. Example 4. Example 4. All right, so this is example 5. Oops. And this is the data for example 5. It is about the areas for quality control. Okay. So our task is to fit the data into the model and then make prediction or forecast. The original data, this is the original data. Okay. So before we fit the data into model, first thing we need to do is to explore data pattern. Okay, because we already did this many times, so I will just skip the procedure, directly jump to the graph. Okay, so this is the example 9.5. So this data looks like a stationary data. It is changed. Let's move this. It is changed around a constant. So this is a stationary data, means we do not need to do the difference. Next, let's check the ACF, autocorrelation function. Autocorrelation function, do I have that one? Yeah. So autocorrelation function shows there is a significant, like at the time, like 1 is significant. Okay. And this is the partial autocorrelation coefficient. If you compare if this is the ACF, okay, usually people will based on ACF and partial ACF to identify the model. So I will use this example to illustrate. Okay, how do you identify a model based just on ACF and partial ACF? Okay, so this is ACF, and this is a time lag 1 is significant. After lag 1, it is cut off. So the rest are cut off. Okay. And then the partial correlation, this is lag 1. After lag 1, the other is dying out or decay. If you have this pattern, the ACF is cut off and the partial ACF is dying out, that is an indicator this belongs to MA model. Okay, so if I go back to the textbook, where's my textbook? So there are theoretical models based just on ACF and partial ACF. This one. oops. So if you have textbook, go to page 401. So the one I showed you, so autocorrelation, it is cut off, okay? And the partial autocorrelation like this, that is an indicator of this is MA1 model, MA1 model here. This is this model, okay? So based on this theoretical model, we are going to propose, for example, 9.5, we can propose MA model. Okay, specifically, it is a MA1. Okay. Okay, now let's set up the model. So this is 9.5. I'm going to open this. 9.5. Is this the one? No. Looks like not. This is not the data file I need. Need to open another one. 9.5. Okay, this is the data. Okay, if you have textbook, page 420. Okay, so based on autocorrelation and partial autocorrelation, we propose MA1 model. Okay, so how do I write down the model? Go forecast, traditional model, and then move this into variable box, ARIMA. I need AR1, so type in 1, okay, continue, statistic, check out the parameter estimate, forecast, and then plot, save, forecast, options. I want to forecast observation. The original data have 90 cases, so I want to forecast for 91. Click OK button. Okay, so now you get the parameters, the constant. The constant is 0.15, and AR1 lag. Oh, this is sorry, we should fit MA1 model. This is AR1 model, okay? Remember, based on our theoretical model, we should fit this MA1. But what I did is AR1, sorry. So I'm going to quickly produce our MA1 model. So analyze, forecast, traditional model. And then, so we should do MA1. So should 001, 001. Everything else remain the same. Just click OK. So this is our parameter, constant 0.151. Okay, and the coefficient 0.582, and our forecast for 91 is 0.43. Okay, so this is our model. We get it. Okay, so this value constant. Remember, this constant is our mu. Because this is MA model, we use omega. This is our omega-1. So the model is YT equal to mu minus omega-1 epsilon t minus 1 plus epsilon t. This is our model. When you do forecast, we do forecast for 91. So Y91. Y91 equal to mu. Mu is 0.151 minus omega minus 0.582 times epsilon t minus 1 is estimated by epsilon t minus 1 means E90. When you do forecast, epsilon t is 0. Okay, so keep on going. 0.151 minus 0.581. So where is my E90? E90 go back to original data. E90, so E90 equal to negative 0.96 minus negative 0.48. Okay, the result is negative 0.48. That is E90, negative 0.48 plus 0. The result for my handwritten is 0.43. It is match the computer forecast, say 0.43 for time period 91. All right, so this example, we introduced theoretical model. If based on autocorrelation looks like this, partial autocorrelation looks like this, it is indicate it might be MA1 model. MA1 model, so looks like this. Okay, so this is the first time we mentioned the theoretical model. How do we use the graph to identify possible candidates, to identify the candidates for the model? Any questions? Okay. All right, so move on. Example 9.6. Example 9.6. This is 9.5. Okay. So example 9.6. Again, we'll do the normal stuff. We'll create a sequence chart. Okay, so this is the data for example 9.6. Those are the data. And how many of them? 80 of them. And we are asked to forecast for 81. But before we do forecast, we want to explore data pattern. So this is the chart. Looks like data is a stationary data. It is changed around the mean value 0. Okay, and then check out the autocorrelation functions and the partial autocorrelation functions. The purpose of these two graphs will help us to identify the appropriate model. Okay, so let's do this one. This one is, of course, the first one is very significant. So time lag 1 significant. After that, it's dying out or decay. When you look at the partial correlation, the partial, this one is significant. After this one, it is like the cutoff. It is significantly, it is cut off. Okay, and once you identify those, let's check out the theoretical model here. See, dying out, autocorrelation dying out. Okay, and partial correlation is cut off, either here or here. That is an indicator of AR1 model. AR1 model. Okay, so this is an example. Is this Example 9.6, we propose AR1 model based on autocorrelation. So now let's do the data. 9.6. This is 9.5. I need 9.6. So open 9.6. So those are the original data. Example 9.6. Okay. We are going to propose AR1 model. This time, I have a little quiz for everybody. Okay. So listen up for the quiz question. To do AR1, go analyze, forecasting, create a traditional model. Click OK button, move into variable box, select criteria for ARIMA. So it is AR1, so just typing 1, click continue, statistics, parameter estimate, display forecast, plot, check out those two plots, and save, predicted value, options. Our data original has 80 cases. So we want to forecast for 81. 81. Click OK button. All right. After you click OK button, so what? Okay, so we are here. So let me go back to my result here. So we did that. Yeah, we are here. This is the output. So now I have a question for everyone. I will pause for a moment to want to hear from you. How do I write down equation based on those parameter estimate? That is my question. Anyone? How do I write down the model based on this? Do I have volunteer?
So first you would have to find pi or phi. I forget how to say it.
That's great. So you have to do the calculation for phi 0. Remember, you need to calculate phi 0. Okay. Who is speaking? Krista, thank you. Yeah. And thank you, Matthew, for that. Matthew, who is that? D. Can you state your first name? Slavia. Oh, Daniel, now I remember. Daniel, great job. You got 100, okay? You got 100. Okay. So based on this, remember this is AR. You cannot directly use constant. Instead, you are going to calculate phi 0. That is the real constant. And you use the constant from the SPSS times 1 minus the AR like 1, 0.494. Remember this for AR model. There are several questions in final exam where about this. If you are attending today's class, you are lucky because you know this, okay? And for people who missed today's class and who don't watch the recorded lecture, they directly use this constant wrong. You have to do this calculation to do phi 0, okay? And this result is 0.02. 0.020. So once you get that phi 0, and this number 0.491, that is phi 1. You have phi 0, you have phi 1, you can write down equation, okay? So YT equal to phi 0 plus phi 1 yt minus 1. This is the AR1 model. It is the same as ARIMA 100. Okay, so you plug in the number 0.0202 plus 0.495 times y minus t. This is your model. Once you get this model, predict for AD1. So just plug in y81 equal to 0.02 plus 0.495 times y90. Y90 is 1.06, and you get the result for y91, 0.5449. 0.5449. Okay, so this is our handwritten calculation based on the model. And what is the computer give us? The result. So the computer gave us, where is the computer result? The computer gave us the result is 0.54. Pretty close. It's the same as our hand calculation. Forecast for AD1. Okay. All right. Any questions?
Professor, I have a question here.
Yes.
It's related to the final. So as you know, if we use the SPSS to calculate for the forecast of AD1, for example, if we just do the manual calculation, it could be slightly different. Will you get that as a multiple choices, or we just need to type in the answer because it will be slightly different, right?
I will give you multiple choice questions and short answer questions, both.
Okay.
Okay. When I give you the short answer questions, I'll try to make sure, for example, keep one decimal place or keep the whole number so that there will be no ambiguity. Okay.
Okay, thank you.
Thank you, Benny. Any other questions? All right. So now let's go to next example, 9.7. 9.7. This is 9.6. Okay. Again, this question is about stock price. Okay. Stock price. So first step, you plug in the data to create a sequence chart. Looks like it is changed around 250 stationary data. And then you check out the autocorrelation function. And this one, like 1 is significant, like 2 is significant, and they are dying out. You see, they are dying out. And the partial correlation, like 1 is significant, like 1 is significant, and it looks like they're also dying out. Okay, and if you have this pattern, and then you compare the theoretical model. Those are the theoretical model. So this is MA. Let's go here. Okay. So looks like this one here. Okay. Because you have dining out. Okay. So we are going to actually propose ARIMA, ARIMA model. Because the data pattern shows It is stationary data. We do not need to do the difference. So the model we produce, ARIMA, or it is the same as ARIMA 101. So we are going to propose this model without differencing. Differencing is 0 because it is stationary data. All right, so let's do the fit the model. So this is 9.7. I have to open data first. See, 9.7 is already opened. Open a new window. So this is a 9.7. This is the data about a stock. Okay. So how many total number? 65. 65. And we are proposing ARIMA 101. Okay. And we already did the chart analysis. I have to. Actually, we propose two models. We do 101 first. So go to forecasting. Traditional model, click OK. And ARIMA criteria 101. Continue. Statistic, check out the parameter, display forecast, plot, check out residual plot for autocorrelation, save, predicted value, options. First case, after observation, original data we have 80. So we are going to predict 81 and 82. Okay, this time I'm going to predict two values, 81 and 82. So you type in 81, 82. The computer knows you want 81 and 82 because it is said first case after end of estimating period through a specific date. Okay, so this way you predict both 81 and 82. So click OK button. So here we have these three numbers as our parameter. Okay, and remember one student asked, when do I use phi? When do I use omega? When you have AR, you use phi. When you have MA, you use omega. Okay, for the coefficient. So this is, let me check my notes. So this is the model. You can write down the model based on this. And for the graph, looks like they're all within the upper and the lower limit, those graphs. And for forecast, did I quick forecast? Oh yes, I did quick forecast. Actually, I mistakenly believe original data is 80. Actually, original data, it is just 65 data. That's why when I type in 82, it gives me lots of forecasts. See, here, give me, if I move this, give me up to 62. So it is forecast from 66, 67 until 62. It gave me a lot of forecast. So original data only have 65 data. Okay. So this is a ARIMA 101 model. 101 model. You could produce another model. Okay, so for this example, you can produce ARIMA or you can produce AR2. Because based on this graph, looks like the first one is significant. The second one is also significant. This gives you the indicator. Maybe you want to produce AR2 model as well. Okay. So now we are going to do AR2 model. So analyze forecasting. Traditional model. So this time we are going to create AR2 model. So it is 002. Continue. And everything else is the same. Plot, save. This time we just maybe 60, maybe 67. Just forecast 2, 66 and 67. Okay. OK button. So this is your why I got AR. So I said, I want to do AR2, but it gave me MA because I did wrong criteria selection. Sorry about that. The one I did is MA model. What I really want is a AR model. So nobody point out. Maybe I'm too fast. So I need to do 200, not 002. I need to do 200. That is AR2 model, not 20. 0. Okay. Everything else remain the same. So I just click OK. So this is AR2 model here. This is AR2 model. And just a reminder, when you have AR model, you need to do calculation for this constant. Okay, you need to do calculation for phase 0. But how do you do calculation? Here we have 2 time lag. Okay, so this is the one I'm going to go to. Okay, I will see if I have the output here. Yes, this is the one. And how do you calculate phase 0? Okay, phase 0 equal to 257 times 1 minus like 1, that is a negative 0.319, then minus like 2.212. So the result of phase 0 should be 285.407. Once you, okay, that is phase 0. And this like 1 is phase 1, like 2 is phase 2. So the model is obvious. So yt equal to phase 0 plus phase 1 yt minus 1, phase 2 yt minus 2 plus error term epsilon t. Okay. All right, so this is example 9.7. 9.7. We proposed 2 models. Okay, any questions? All right, so in summary, what we did today, we actually, in later examples, we did theoretical model. Remember the dying out, cut off for ACF function and the partial ACF function. Based on that, we have theoretical models. Those theoretical models are referred to this. Based on these theoretical models, will give us some suggestions on what model we should build. Okay, so after you decide what model you need to build, you just perform the standard procedure in SPSS. After that, you based on the parameter to write down the equation. The only thing need to point out, when you have AR model, you need to recalculate the phase zero. That is the only thing you need to pay attention. When you use R, you also need to recalculate phase zero. When you use mini tab, you do not recalculate phase zero. The mini tab automatically give you phase zero. Okay, that is all for today's lecture. Thank you so much for your participation. I appreciate your participation. Okay, you have any questions? I do have maybe a few moments. If you don't have questions, feel free to go. Good luck on next week test. And I will see you. We don't have lecture during the test. You have questions, I'm checking my email. Okay, thank you again. Take care of yourself and your loved ones. Oh, remember the COVID numbers are going up. Be careful, okay? Thank you, Daniel. You mentioned yeah. Thank you, Ali. Thank you, Krista. Thank you, Matthew. Thank you, Danny again. Thank you, Benny. Thank you, everyone. Okay, good night. Bye.